Welcome back to Advent of Code, day 4. And the quiz of today I have already solved in advance because, to be honest, it took me a little longer to get this out. But I will quickly explain what this is all about. So as you can see over here, we get a grid. This is our input. And in this grid, we have to find the word Xmas, right? Now the word Xmas can go in any direction. So it can go diagonal like this. It can go from bottom to top like that, right? It can go from left to right. It can go from right to left. And it can go from diagonal bottom to diagonal top, right? So for example, X, M, A, S. As you can see over here, we have Xmas, like that, but it goes in this direction. So it can go diagonal, like this, in any direction. And it can go horizontal and vertical in any direction. So, I've tried out many attempts, and I did it with structs and enums and stuff like that until I found out it's not really necessary to make it that complicated. So what I did was, we first iterate over each line, right? So line 0, 1, 2, 3, we iterate over every line, and in every line we iterate over every char, right? So we iterate every row and every column, right? Until we find an X, okay? And then what we do, if we have the word Xmas, right? So we then have the first letter. So letter at 0 index, we have it, right? And then the next thing we do is we check every direction. So if we go over here, does it have the second letter? No, it's an X. If we go like that, does it have it? Yes. All right. And then we go one further. So A is at index 2, and we again check every single direction. And as you can see over here, we find an A. And then at the third index S, and we find the S again over here, right? And we can do that for basically every direction. And let's see. So, spin, this is day 4. So the first thing is I will grab this input, like that. And then what I want to do is I want to parse this input into a vector of bytes, right? So what I want to do is I have a variable grid, and we can call this function grid from input, and then we should have a variable of type grid, right? At the moment it's unknown. So for this we create a grid struct. It should have bytes field, which is a vector of u8. So the outer vector represents the rows and the inner vector the columns, right? And the u8 will be the byte of the chars. Then let's also do rows. This should be usize and calls usize, right? So this is just makes it easier to read. And rows is basically the amount of rows in the outer vector, right? And calls is the amount of chars on every line, okay? And we have to implement this from function, and for that we implement the from trait. we convert from a string slice to a grid. All right. The input is of type string slice, and we get back self or grid. Can use either way. So let's first start with the bytes field. Again, this should be a vector of bytes. We get the input, we iterate over the lines, and then we map. All right. So we then have a row, right? So each line over here we iterate over represents a row. And then from the row we take the bytes and collect. This is the inner vector, right? This over here. And then again we collect to get every inner vector inside an outer vector, right? And let's do rows and calls. So the rows field just is the vector length, right? And the calls field will be, let's take the first line or the first vector inside the outer vector. And then we just map. If there isn't a first element, we return 0. Otherwise, we have found a row. We take the row length, right? Then we can construct this instance, rows and calls, right? Like that. And as you can see now, our grid variable is of type grid. Right, and to show you what this looks like, let's implement, or let's derive the debug trait for grid, because then I can print it out. Okay, let's see. And let's do, oh, I have to take the test input and not the real input, like this. So as you can see, this is what this looks like. We take this input over here, and it will give us a vector with inner vectors. So each of these inner vectors represents a line from here, right? And it gives us back the value in bytes, right? Basically the ASCII code. And as you can see, we have 10 rows and 10 columns. So 10 rows and 10 columns. Nice. So we can remove that. And let's see. Then what we can do is, I will do a count variable. This we will need later. And now we can basically iterate. So we iterate over the rows. And let's do flat map. And flat map allows you to map over an array and do some operation and then flatten it. And that's what we want, because we don't want nested vectors. We want a flat map. So we get back, so we get the row. Let's go from 0 to the column's length. Map. We have to move over here to move this row variable. And we iterate here over columns, and then we can return a tuple with rows and columns, right? So we iterate over the rows and columns, and then we return the current row and column we are in each iteration. Then we can filter, and filter takes a reference, so we pass row and column, basically the returned tuple over here. And let's say grid bytes, row and column, right? And we compare that to x, okay? Because as I've said, we iterate, and if we find an x, we will do further function calls. And then for each Again, we take row and col from over here. We increment the count if we find Xmas, okay? If we find Xmas, and then over here we return the count as U32, okay? Now, as you can see, we haven't implemented this Xmas count, so let's do that right now. And yeah, let's implement this function, or let's do it in a method. So function Xmas count should take self as a reference, row usize and column usize. Okay, and we return usize. And then what we do is we should iterate over every possible direction. Okay, so I have over here the directions. So if we found an X, then we check each direction if it has the next following letter of the word Xmas. So if we find an X, we check for an M, and we have to check that in each direction. Okay, so we can do that with this slice over here. As you can see, this slice contains tuples, one for the row offset and one for the column offset. So for example, the first one is 0, so we stay in the same row, and 1, so we check right. Okay, from this X we check right. The second one would be left, right? So we stay. The second one would be 1 down, so +1 and 0, so we check down. 1 1 would be 1 1 diagonal, right? And so on. So we check every single offset. So we iterate over this, and then we filter. So we have offset X and offset Y, right? And then in this we have to iterate over the char index, right? So the index of the word. Because Xmas has 4 letters, we iterate from 0 to 3, right? 4 is not included. So let's call new row as isize plus the offset X times I. The same thing for the column. And this is offset Y. Okay, like that. And we do that because, let's say I have the word Xmas, right? I have here the word Xmas. So we have 0, 1, 2, and 3 index. And we iterate over every index because we have also to consider the offset of the word, right? So we have here the offset in the grid times the offset in the word. So if we start from this X over here, right? If we look for M, we offset by 1. So we multiply this offset, for example, the row offset by 1. Okay, but if we look for A, we have to offset it by 2. So we multiply this by 2, right? Because, for example, we found X, we found M, and then from X we have to go down 2, right? And this we do for every single direction. And then let's call self get new row, new column. We compare, is this the letter I in the word Xmas? Now, as you can see, we haven't implemented the get function. So let's do that. Fn get, again we take self, row isize, call isize, we return a U8. And we just do this function to make it easier, so we can write it more concise like that. So we take the bytes, the grid, and call the get function. So row as usize, and then if we found a row, then in the row we get the column also as usize. And if we didn't found anything, we just return a point, right? A dot. Like over here, if we don't find, we return a dot. Okay? And we return here a reference to U8, so let's dereference that like this. Right, so instead of writing this over here for every single time, we also in part 2 we have another function. We do it like that, so we can call this and it looks more concise. So again, in every iteration of these offsets in the grid and the offset of the Xmas word, we have then a new row, a new column after these calculations, and then we get the letter with this function over here. We get the letter in the grid at these new offsets, and then we check, is it the right letter at the offset I we are currently iterating, right? This has the all method over here, meaning all of the conditions, meaning all of them have to be true, right? So in every single iteration over these words, every single one has to be true, so we get Xmas, right? And then all we do is we count how many times we found it, right? And that's basically all we have to do, right? So when we do cargo solve for release, we get 18. Let's see, and this is correct, okay? Then I can remove over here the test input. Let's copy it for part 2. And I take the real input over here. Let's see, cargo solve. Okay, and let's try to submit that. And that's the right answer. All right, we finished part 1. Now let's see part 2. Reload. And in part 2, we actually have to match mass, the word mass, but it has to match in an X form, okay? So mass and mass, like that. But it can also be mass and MAS, right? Or SAM, SAM, right? So we have to consider that. So in the same input from before, we have over here mass and mass, like this. And we have here mass and mass, like that. So mass, the word should be in an X form, okay? And to do that, we basically do the same thing like we did before. Let me actually copy. Like that, okay? Again, we take the test input, test, and this time we won't need a counter because we do it directly. And this time we filter when we match an A, right? Because every time we iterate, we are looking for an A because A is constant. These can change, right? So for example, we can match SAM or SAM or SAM like that. But A is always in the middle, so we go from the middle point, okay? And then let's do over here filter, like this. And then we return the count directly this time. So we can return it like that directly. So we don't need that. And as you can see, we have to implement cross mass count. We have to do that in a separate function. So cross mass count, and let's implement that. Again, we take reference to self, row, as usize, column as usize. And first of all, I convert the row and column to isize. It will be easier to work with it when we do minus operations, right, or subtractions basically. So first of all, I convert them, and let's check for diagonal 1, right? So we can use this get method we have written in the past exercise. So we get row -1 and column -1, all right? And we get row +1 and column +1, all right? And the same thing we do for diagonal 2. We do this plus, and over here we do minus, all right? So I have to explain that so we can see it better. Again, we parse the grid, then we iterate over the rows and the columns like we did before. And this time we only call this function over here if in our grid at the row and column the letter is A. Okay, as I've said, we concentrate on the A's because it will always be A in the middle. And then only if we found an A, we call the cross mass count and we pass the current row and column. And in the end, we just count how many times it returned true. Okay, so we are here, we get the current row and column, we iterate over, we convert it, and then we call this get function, okay, to get the letter at the index we are passing. So row -1, let's suppose we iterated over this and we get an A, right? Then we call this function. So row and column is the index of A. And then we check for diagonal 1. So row -1 would be like this, and column -1, excuse me, row -1 would be one above, and column -1 would be left. Okay, so we check here. And the second thing is row +1. Row +1 is here, +1 column is here. Okay, and diagonal 2 is the same thing, but for this diagonal over here, right? So we get 2 slices, and then we can take these diagonal 1, diagonal 2, and we iterate, and all of these have to return true, right? So when we get the word, we check, is the word ms or is the word sm? Okay, that's all we do here. So if the first diagonal ms, then it's true, right? And if the second one is sm or ms, either way it returns true. And if both of them are true, then it returns true over here in the filter, and we count it. And that's basically it. Let's check if the test input is true. 9, right? This is true. So we can remove the test and put the real input, and then we can submit to, and as you can see, that's the right answer. All right, see you in the next one.